So today's is a very special evening. And by the way, thanks to Londroid and Wise for having me here. The special evening is so special because I'm not talking about Kotlin. But I mean, this word will pop up throughout this talk, but the talk is not strictly about Kotlin. Okay, so I'll be talking about like my sort of brain dump on how GenAI may or may not affect the software industry. This is very speculative. I'm sort of betting money on what I'm talking about. So it's, a thought through speculation, but I'm not advising you to bet money on this too. Okay, so who had a heated debate about how some GenAI tool is going to change software industry in the last 3 months? Show hands. Okay. Oh, all right. So you actually care. That's great. Yeah. So I'll give you some of my thoughts, and we'll try to make it more of a conversation than just a lecture. So the overarching questions I'll be trying to address here is whether some GenAI stuff will replace programming languages as such, or even human programmers altogether. So one question that pops up here and there that I'm not addressing today is whether we can make existing languages or new languages sort of similar to existing ones into something that's easier to generate through LLMs. I have no idea if we can. I've tried to think about it and talked to experts about it. It looks like there's little we can do, so I'm not talking about that. But everything else about programming languages and human programmers is in scope today. All right, so here is what I think is the landscape for different kinds of code manipulation tools nowadays. So who used something like CoPilot or some other advanced code completion tool? I did. Okay, who loves it? Okay, not everyone, interesting. And who uses just an LLM instead of that? Fewer people. Okay, so code completion tools are obviously mostly useful, at least to some of us. There is chat functionality in most of them, so you can chat with CoPilot or some other AI assistants about your code base. Who's using that? Okay, not so many, and I never do actually somehow. Although I mean, it's kind of on paper, it looks exciting that I can ask a bot about something in my code base. Somehow, I don't know why, I never got around to using it often. So, and third is coding agents. So some clever AI that can generate entire programs for you. Who uses that for hobby or for work? 2, 3? Okay, not so many people. All right. Who tried anything like, I don't know, Lovable or Aider or something like that? Okay, so the same 3 people. Okay, so maybe I'll give you a very short overview of what's going on there. So the idea of coding agents goes like this. If we not only have like a single prompt code generation, I ask ChatGPT or Claude or something else to spit out a piece of code, and it basically guesses at what it needs to do without, maybe with my existing code in context or without. I can actually do more. I can ask it to plan the implementation. I can ask it to look maybe at some other context, like my commit history. I can allow it to run tests, for example, and if the code it generates breaks any tests, it can rerun tests and see what breaks and make a fix, so on and so forth. So this becomes more of an active participant in software development. This is why we call them agents, right? So, and there is a leaderboard for different coding agents. Somebody put together a list of sort of benchmark tasks for them. There is 500 tasks on pretty popular repos, many of them sort of data science related, but not all. Django is there. There's over 100 tasks about Django in this, and people have a leaderboard, and today's top result is 62%, almost 63% of the tasks in the benchmark get solved automatically by an agent, which is, I mean, not bad. We're still not there yet. But the interesting thing is all the leaders are pretty close together. Like the 11th one is only 52 against 62. So everybody's on the same page, more or less. And they all make steady progress. So sooner or later, they will be solving these problems reasonably well. And the problems go something like this. Here is a top commit in your repo, and here is a test that I want to run, and here is the problem statement, like the description of what I want to do. And yeah, just go figure out what kind of changes you want to make to this repo for my task to be completed and for my tests to run. And those are sensible things that, like, basically fixing GitHub issues across popular repos. So this will work. It doesn't work for like all projects yet, but it's safe to assume that it will improve over time. And so the other day, I just made a small case study about a very simple app. I tried to just took some readily available agents that you can prompt to create apps for you, and just wanted them to create all of them the same thing, a to-do app, like a personal to-do app. And I wasn't describing it in any detail, just said I wanted a personal to-do app. That was it. So, and those are 4 examples from different agents. I'll give you a few details, but the basic takeaway is they all managed to produce a usable to-do app. Some of them, in the initial versions they made were ugly, but they all worked. The bugs I saw, they could fix on their own. Even the one who that produced ugly UI could fix it and make it less ugly. So, you know, you can actually use it to create simple apps, and they work. So here is an example of a result I got from bold.new, for example. And all I asked it to do was do a personal to-do app. It figured out it needs some UI for editing a task. It needs to cross out a completed task, like it needs a delete button, so on and so forth. So all that more or less worked out of the box. And here is just a comparison table for which agents figured what out. So I tried REPL.it, Lovable, Bold.new, Cursor, and Claude. I also tried ChatGPT, but it didn't fit in the screen here. They can all do a lot unprompted. So, for example, Bold figured out that it needs some design. It needs to create a to-do, mark done, a delete button, unprompted. So I didn't explain what a to-do op should do. It just figured it out. And then if I asked to add an ability to edit text, it did it. Reorder to-dos, it did it. So on and so forth. Like store the data between page refreshes, it also did it. So, you know, it can do basic things. And some of them can even spin up a backend database and store the data properly, so on and so forth. So, you know, in general, this is not bad. Like, we're obviously making baby steps here, but it's promising. Any questions or experience to share about this? All right. So just setting the stage, like some of those applications, some of those agents are kind of fancy websites that host your applications, you know, and actually they charge you quite a bit of money. This is Claude out of the box. And I didn't even need anything to run this because Claude runs it for you. It's obviously JavaScript, but still. So it also did everything I wanted it to do, a little bit more prompting. But in general, you don't even need an agent for such a simple app. For more complicated things, you will need an agent, but Clo 3.5 is good enough to solve this. And this is what Cursor does. So the UI can be improved. And the thing is, you can ask it to improve the UI, and this is what it does. So basically, I mean, all I asked was make the UI prettier, and it became prettier. I don't know why it doesn't do it by default. But, you know, so this is pretty usable on a very basic level. And this makes me think, like, what else can this kind of technology do? What else can we expect from this? By the way, this is ChatGPT after some prompting, so it's also decently doable. I started with this before the last update, I think. So my initial version required a lot of prompting. I think 4.0 has like much less prompting. But basically, I can explain to a model what kind of application I want, and it will do something sensible in response. So while I was experimenting with this, there were issues. One, it's incredibly annoying to wait while it's generating, especially Replit is like it's an actual agent that inspects its own code, it runs its own code, it takes time, it can take a lot of time. Like I was distracted all the time, this compiling, compiling comic from XKCD. So I was, sword fighting in the hallways a lot while it was working, but it did create the most functional one with a proper backend. So, extra points for that. And also, they all ignore data migration. Like when I change anything about how my to-dos are internally stored, like add date storage or create hierarchy for to-dos or something else, all my existing to-dos are lost every time. So, there is some way to go with all of this, but it's very promising. So why am I talking about this? My basic assumptions in this talk will be coding agents are getting better and will probably be able to generate useful code for most sensible prompts. So it's probably going to be no worse than a junior developer and maybe will be as decent as a mid-level developer in like a year, 2, 3 or so. Still, I'll be talking about the pre-singularity world. So I'm not talking about the world where the machines are so smart that we can't figure it out what they're going to do. So if we get something called superintelligence or whatever you want to call it, something that's much smarter than humans, there is no predicting the future. And since I'm here trying to predict the future, I'm not talking about this. So if our machines are smart enough to do everything that humans can do, there is no conversation. There's probably no humans. So I'll be talking about pre-singularity world, and I'll be talking about applications and not system software. Okay, any questions at this point? Go ahead. Okay, so the question is the comparison between Claude versus ChatGPT versus Cursor is not really fair because Cursor uses those two underneath. True. So I'm basically comparing not the models themselves, but they're like the UI they provide to me as just an end user. And yeah, so everybody uses everything. It doesn't matter. Like I don't know what other agents that I tried even use. Maybe they use both Claude and ChatGPT. Maybe they use something else. There was another one. Go ahead. You mean the to-do app? Hmm? All right. Yeah. So it's a very good point. So my a to-do app is something that everybody knows what it needs to do. So there is no explaining required basically for it to figure out what I expect from it. It probably saw a bunch of to-do apps while training. So, it's a very sort of easy, straightforward example for them. But the interesting bit is it's not only like figuring out something from a very small prompt, but when I keep prompting it and asking to add features, it still can do it incrementally. It doesn't generate a completely different app every time, which means it can incrementally improve the code base. There are nicer benchmarks, but they won't fit into a talk like this. Okay, so that was the setup. Let's talk about something more real. So, it takes time to learn how to program. And it's a good question, like maybe given all this progress, we can actually eventually program in plain English because plain English is a little more accessible than programming languages, especially for English speakers. So it will probably save us a lot of money and will save people a lot of time on training, right? So does it mean we are losing all our jobs? Yeah, if you haven't seen this, it's a very good meme. Yeah, so programmers are worried about ChatGPT and mathematicians survived the invention of the calculator. Asking first time. Yeah, so this is our first time, probably not the last time. So if we think about it, generative AI can basically raise the level of abstraction. Before, I had to explain in a lot of detail what I mean by nice UI. Now I just say, give me a pretty UI, and it figures it out, right? So it's basically, we go from detailed code. I would have needed to write a lot of CSS and HTML to get from what Cursor gave me initially to a nicer version that it gave me after a very short prompt. So this short prompt actually carries a lot of information. So I raised the level of abstraction and removed a lot of noise basically from my day job, which is nice. Analogy, many years ago, Kotlin raised the level of abstraction for Java. There was more Java code to express the same thing we expressed in Kotlin. So we can do the same with less code, and it also kind of knows what we mean. So it captures the common patterns. You don't have to use so much boilerplate. And when we talk about boilerplate, it's basically this redundancy. Like, what do we call boilerplate even? Boilerplate is code that you hate writing because it's obvious. You also hate reading it because it's obvious. And also, if it's mostly obvious and there is one little thing somewhere in the middle, you'll definitely overlook it and you will debug for days to find it. So this is why boilerplate is bad. This is why Kotlin is sometimes more productive than Java, because it collapses lots and lots of boilerplate into smaller things where it can actually see information, like signal to noise ratio is nicer. And you can think about the same, like if we can infer some code from whatever context we have, from prompts, from documentation, from some other form of expression of the same idea, it means all that code is boilerplate now, because we don't need to write it, we don't need to read it, we don't need to interact with the code in its detailed form. Wouldn't it be nice to remove all the boilerplate in the world? What do you guys think? No objections. Everybody's losing their job. Okay. All right. So let's think about coding in plain English. What can possibly go wrong? Like, let's say, like we have a system that legitimately can enable us to program in plain English. And we work on a real life project, like, I don't know, we created like a delivery app or like a banking app or something. What can go wrong if we just do it in plain English? Your skepticism is very welcome. Mm-hmm. Natural language can be ambiguous. Good point. Go ahead. Well, we'll deal with that. Yeah. Okay. I don't think I caught the last one. You written test with Cucumber and? Okay. Yeah. Yeah, go ahead. Yeah. Yeah, at higher levels of abstraction debugging can be harder because abstractions leak in unobvious ways, and you may need to look under the hood. Good point. Any more? Okay. Okay, so you're saying it may see less of a context than is actually relevant. Like it can consider only part of the context instead of the whole context. Okay, okay. All right. So I won't be able to address every concern. I have a bunch of my own, but the ambiguity one is very important. So when we say something in English, it can be ambiguous. And this is why we have legalese, where people really try to make things unambiguous, especially if they're working legitimately. But you've probably read a contract in your life, and that's terrible. I'd rather write this kind of thing in a formal language than a natural language because it's so difficult. The interesting thing is, like, there is a dialect of English which is not so legalese, and it can capture a very precise like set of abstractions, but it's still not a formal one, which is the language of research papers on mathematics. Like most mathematics that's published out there is not written in a formal language. It's written in a mix of plain English with certain terms and certain structure with definitions and proofs and everything, and formulae. And we are able to capture enough there. So there is a gap, like to turn a paper on mathematics into a formal proof, you usually need to create a proof that is much longer than a paper, like dozens and dozens of times longer. So the question is, are LLMs smart enough to figure all of that out? And the good thing is they don't have only one shot. They can try and fail and test and try again and so on and so forth. So I personally have a hope that we can try to find this balance. Like, it's not like you'll be able to write any English and it will magically read your mind. And also what you have in your mind is ambiguous by nature because we humans don't consider all the small special cases. But in a dialogue with a system, you'll probably be able to figure it out enough for it to capture the actual intent. So that's a challenge, but I think it's addressable. There are other challenges that I wanted to talk about today. Challenge number one, let's say we are trying to create an application of some complexity, something like a delivery app, or like it's not actually an app, it's at least 3 or 4 apps and a huge backend system, right? Or we're creating something like Microsoft Excel, for example, like a spreadsheet software, or whatever, like a big end user application. To explain to a machine what this thing is doing, it will take pages and pages of English. So it's not as long as its actual code. So we will save on space, but it's still not something a single person can write in a reasonable time. So we will have to do something about that, right? So we can't have an enormous prompt with no structure, because there is no way you and I can collaborate on that in a meaningful way. There is no way I can find a year after I've written something in this prompt, I can find the right place to change something. So this lack of structure will definitely kill us. It's like if you try to imagine how hard it would be to write something like Excel in assembly language, that's going to be similar. Like assembly has a little bit of structure, but like not much, and software is huge, right? So here, the level of unstructuredness will be similar. Or if you ever try to model a big system in a graphical language, like whatever, a state machine or something, that gets out of hand very quickly, although it's a formal model, right? But you have to navigate at like acres and acres of diagram, and there's no way you're making any sense of it. So structure is a problem. Another problem is reuse mechanisms. In this huge prompt, there will be similar parts, not exactly the same, exactly like in programming languages. We want to reuse this to make sure A, it works consistently across the system, and B, that we just don't have to define it every time. And that, I mean, English doesn't help us there. We can try to create an ad hoc notation and say, okay, here is a thing I want you to reuse in multiple places, and just hope that the model figures it out. It might not. So that's another challenge. And yet another one is, let's think about predictability in general. Like, let's say we have like a big prompt, we figured out how to structure it, we figured out how to collaborate in it, and then we just updated the version of the model we're generating everything with. And it's now generating different code for everything. And it used to be semi-predictable, like we could fix a seed there, we could lower the temperature to 0, so we could make a single model more or less deterministic, but then the vendor of the model just updates the current version and everything changes in subtle ways. Things change all over the code base and we have no control over it. It would be a little tricky to handle. Also, when I change something within a huge prompt, I cannot predict which parts of the actual program will change. It may easily redo everything. It may be still correct, but the diff on the code will be enormous, right? So, and we'll have to deal with that somehow. Like if we have a huge prompt, it's not like we can control changing a word in it, affecting this or that part of the system, right? And the point about debugging, I also had it here. Like when I have a declarative, descriptive prompt that tells what I want to get in an application and it doesn't behave right, I can't step through the prompt. There's no correspondence between the prompt and the actual application. And this is actually a common thing for all declarative languages. It's very difficult to debug things like lazy functional languages like Haskell, or debugging Prolog is very difficult because it's declarative. And declarative things don't necessarily have a natural order of evaluation. So there is no notion of next step, or the actual runtime notion of next step is very counterintuitive for a human, like in Haskell, for example. So, you know, here it's a big challenge. Any more challenges coming to mind? Go ahead. Mm-hmm. But it won't change your prompt, even if they could be mistaken, and people are not perfect. Mm-hmm. Right. That's a very good point. And I think this is something absolutely fixable. So in my mind, when we get, and actually this is what some of the agents I played with already do. So the model needs to not necessarily challenge the user, but clarify things with the user. And it's absolutely doable. So basically when I say, I want a to-do app, it makes sense to ask me a few questions like, how many users will this app have? Is it only for one person, or should there be accounts? Like, is it only one kind of to-do or multiple? Do to-dos have deadlines? So on and so forth. You know, it makes sense to chat a little bit with the user about like what exactly they expect. And I think we can do a lot there. And we can, I mean, it's important to not ask the user the questions that are A, obvious, and B, that they cannot answer. But I think we can do something about that. Go ahead. Mm-hmm. Right. Which I guess what you're giving up is some level of determinism, because the more deterministic you want it, the more you're going to have to use mathematical reasoning to make it maybe even start to look more like programming language. Mm-hmm. So I think really what we're talking about is just making programming more concise. Sort of, yes. Mm-hmm. Okay, that's a very interesting point. I think Eric Meyer is working on something very close to what you're talking about. Yeah, so to summarize, and please correct me if I summarize wrong. So basically, the English description will be very non-deterministic, and the amount of determinism in what you prescribe is largely governed by how formal you have all this specified. I think this is like formally true. In many practical cases, we don't really care about getting a very precise implementation of something, in the sense that many implementations are legitimate. So for us, it's important to explain what we expect. And you can think about it as basically talking to a human, right? You can ask a qualified person to do a sensible thing here, and they will imply the same things as you do. And maybe corner cases will be tricky, but then you'll test for the corner cases and deal with them. But what's important is to communicate expectations and be able to consistently fulfill the expectations. There are interesting experiments where people embed either pre and post conditions in their prompts or just test samples in their prompts, and that definitely helps generate the relevant code. So, there is some, like, we don't necessarily have to be super formal about what we want. If we provide enough sort of test data and something can make a logical closure over this test data. Okay, any more concerns? Go ahead. Good point. Yeah. So what if we don't, like, our idea is not something that's been done a million times? What if we can't say a to-do app because the kind of app we want to create is not something known and there is no name for it, and we want to explain it in some other way? I think it's still explainable. Like, if you can't explain to another human what kind of code they need to write, you can explain it to a model. It will take more words. So basically, there is this trick of the knowledge of humanity being compressed into a model. It's very convenient because it knows a lot of things humans know, but it doesn't know everything, especially it doesn't know the future and doesn't know your original ideas. So you'll have to explain those as much as you have to explain them to humans. So I think this is fine as long as its sort of adequacy is more or less universal. And so far, what we're seeing is reasonably universal in this sense. So, and by the way, the most precise prompt you can give to get some code back is that very code. You can say, okay, this is the code I want. And that's a subset of plain English, some subset of the prompt language. So you can always resort to that option, but you can probably do better in many cases. Okay, so big question still. Like, I mentioned that we want to collaborate on prompts, right? And so my conviction is that it will still require big teams collaborating those prompts. So it's not like if we're creating something like really substantial, like a delivery app, a banking app, or even spreadsheet software, it's going to require a lot of people thinking hard about how we want to tackle a lot of challenges within this domain. And those people will, do a lot of whiteboard brainstorming and a lot of back and forth over specifications before any code gets written or generated. Doesn't matter. So those teams have to collaborate, and then those prompts will be huge, and they will have to somehow version them. They will have to somehow show each other changes. There will be Git, there will be diff tools, there will be lots of stuff. There will be probably refactoring tools for such natural language, because it becomes the artifact if we think about this well. So I think large teams will have to work on software still, because it just doesn't fit in one mind, right? But if you have any objections to this, please share. Go ahead. Mm-hmm. Mm-hmm. Yeah, that's a very good point, by the way. Yeah, so apart from just specifying what we want software to do, there is so much more. We can, conduct experiments on the user base, like A/B tests. We can try to make sense of all the production data that we collect, and like try to figure out the user behavior and find the ways to help the users better or drive the users to this certain goals and so on and so forth. So all that can conceivably be also included in this. But basically the question is who these people will be, who will be prompting those agents. And in my mind, it can be like, in today's terms, some of them absolutely have to be engineers, because somebody will have to figure out how to break the system into smaller parts for people to collaborate on. It's not so much like the actual agent may not even care how you slice it. But for people to be able to break into teams and work on their pieces team by team, you'll have to figure out a structural way of dissecting the system. So that you will absolutely have to do. And this is the essence of software engineering, if you will. If you subtract writing code from software engineering, this is what's left. Like, you have to figure out how to break down a big problem into smaller ones and to make it maintainable over time. You may not write any code per se. You may write English, but it will still have all those problems applied. And the interesting thing is that with a lot of other engineering domains, it's the same. Like, this is this is what makes software engineering engineering. And conceivably, other engineers will be able to write programs now because they know all the engineering stuff, and that's enough if they speak some natural language. So that's one way of looking at it. Another way of looking at it will be saying, okay, so we'll probably have to test this a lot, right? Because we didn't even write it. We don't know how it works. We have to do a lot of testing. And we have QA engineers, and they can definitely write English. So maybe they just write the prompts and then test the results, and that's going to be a closed loop, and everybody's going to be happy. How is everybody feeling about their jobs? So, it's at least a way to empower people who didn't go through a lot of training with programming, which may be very beneficial, given how much software we haven't written yet. Like, the penetration of any automation in all kinds of industries is like under the 10% of its actual potential. So we haven't written even like half of all software we need to write. So yeah, and so on with the different other specializations. Designers can conceivably write this kind of code, and other people who didn't go through a lot of training with programming can be enabled to actually contribute to working code. So the big point here would be, like, no intelligence, no artificial intelligence will help remove humans from this process altogether, because if humans will be using this, they should be the customer. They should be the ones who specify what they want. Because if, like, you can't imagine a system that just writes software for itself, but there has to be some communication between some humans that are going to use it and the system, right? So there is no way we exclude humans from this process altogether. Before singularity. After singularity, I don't know. Any questions about this? Oh, that's a very good question. That's a very good question. So basically, this is roughly what I'm talking about here. So it may change names, but what humans have to do is to explain to a machine, or it can be a machine, or it can be a team of humans, it doesn't matter. You have to explain what you want, and you have to do what's called acceptance testing, right? You have to make sure that what you get back is what you wanted, because nobody else knows what you wanted, and nobody else can check if it works for you. So it has to be on the human side to somehow make sure that what we get is right. We can definitely use some tools for that, and maybe we can automate a lot of tedious testing with like common sense stuff. If I click on a button, it does something, But in terms of like the actual user scenarios, can a user achieve their goal in a sensible way? Somebody's going to test it. There's no way a machine can just magically know what we wanted and test the right thing. Yeah. Right. This is a great question. So if we're using agents to generate the code or to test the code, who makes sure that the agents are doing the right thing? And if we try to sort of put agents in place of all humans, it's an unsolvable problem. There's no way we make sure, without looking into the box, we can't make sure it's doing something sensible. But an interesting thing is with code, for example, we can have objective measures of how relevant the code is because we can write tests. And tests can be generated, but they'll have to be validated somehow. But the thing is, like, we can have something external to the actual agent checking that the code conforms to something. Like a compiler will check that it's the code in the right language. then tests will check that it produces the right outputs for the right inputs, so on and so forth. It's never going to be exhaustive, but it can be a very good science check. And if you think about it, if you have something like a clean room implementation of a system, or if you just don't like your engineering team and don't talk to them, you still have to somehow validate that the software that they're giving you is working in the reasonable way. So people actually do it already. It will be similar. More questions? Okay. I think something broke here. Yeah, go ahead. From an engineer perspective. So maybe when you put someone without any background exposed to this kind of tools, a completely different way to interact with them will happen. It can be. Well, to the question, do you think we can be biased? Absolutely, yes. Like, no matter what you say after. And yeah, so it can be that people figure out completely new ways of doing this. Unfortunately, I'm from the past. I can't see future better than this. So I'm proposing my own vision, and maybe somebody else finds something else that's better. I don't know. Yeah, so what was I talking about this whole time? So to me, as a programming language person, this looks like we may need a new kind of programming language. And for the record, I can neither confirm nor deny that I'm working on this kind of language right now. So, but if you think about it, it's actually, it looks like a programming language, right? Because we need very similar things. We need some structure that breaks a system into smaller parts. We need it to produce runnable software. We need people to collaborate in large code bases, and all the processes around it will be similar. Yeah, it uses plain English instead of a formal command language or something. But other than that, it seems like a programming language. And if you think about it, it's going to be something like we went from C++ to Java, from Java to Kotlin, from Kotlin to something I call ABPL, because I'm modest as forget-me-nots. So just for the sake of this talk, it will be this acronym. But if you think about what happened here, for example, it was actually very influential. When we went from writing software in C++ to writing software in Java, it was a very big change for the industry. Because here, for example, in C++, we couldn't have 1,000 people with not much skill working a single piece of software because the resulting software wouldn't work. There is no way you take people with, like, I don't know, 1 year of training and put a large team together with like good management and write tons and tons of C++ and it just works. No. But as we saw with multiple huge outsourcing-based projects actually reasonably succeeding with Java, it became possible. Like, you can actually put together a team who'll be writing bad code and a lot of bad code, and the system won't be incredibly stable, but it will actually work, unlike C++. So this was a phase transition in that sense. So we basically going from manual memory management to automated memory management, we created new programmers, a lot of new programmers. We multiplied the number of programmers in the world quite a bit because it started making sense to build those teams of lower skilled programmers. And Java to Kotlin wasn't this dramatic. Like, Kotlin is nicer for some cases, but it's not a revolution here. It just makes people smile because they are happier, which was an explicit goal for us, is you know, like one of the, like the key metric for the Kotlin team was optimizing the curvature of the programmer's smile. So, you know, that happened, but it wasn't like we increased the number of programmers in the world dramatically. But here, we can increase the number of programmers in the world dramatically again, because you may need even less training to onboard people into this, and you can still put together big teams and you can deliver working software, most likely, with this. So if now we have about 30 million programmers in the world, we may have 100 million pretty soon. And the good thing is, it's not going to disrupt the industry in the sense that all the skilled programmers will still have jobs, and I'll explain why a little later, but we'll be able to write a lot more software. And we'll be able to automate a lot of paper pushing, which, paper pushing makes things slow, makes human errors very common. And if you ever dealt with any kind of bureaucracy, you know that. Any questions about this? Go ahead. Well, let's talk a little bit more about this. Maybe, am I going to talk about this right away? No, a little later. So in terms of whether we become dumber or we don't, actually depends on, okay, let me talk about this right now. So if you think about the bell curve, and many things are distributed like this, and IQ is distributed like this, and also skills and mass are distributed like this. So if you think about it, like half of the population, exactly 50% of the population, have the IQ lower than 100. So there's it's high skilled or highly talented people are always in the minority, because it's not the other half, it's actually the, I don't remember, 30% at the top or something. And if we have enough work going on, smart people will be still doing smart things. The problem is whether so many people will want to become smart, will want to learn things down to the metal, and so on and so forth. From my days in a completely managed Java environment, I've seen quite a few engineers looking into actual machine code running on the CPU, because this is how you make Java applications really fast. So my guess would be, it's in terms of food for thought and interesting challenges for engineering intelligence, we're not running out of those. And we'll go back to this a little later when we'll be talking about fixing problems. But yeah, I understand that you can imagine that the sort of average programmer will be a lot less skilled in this system, because out of the 100 million, a lot will not know anything other than this. Go ahead. I wasn't there, but I mean, Flutter will be a very good analogy, although I think this may be a lot more consequential, because Flutter is largely a UI framework, and there is much more than just UI to writing applications, but it was definitely a move in the same direction. Okay, so why it's a programming language? Because basically what we need to address all the concerns we had above will be very programming language kind of things. Modules to structure everything. So we need to somehow explain that this lives here and that lives there. And also we need to localize change, right? So if we want some predictability in terms of, I only touched here, so it couldn't have changed anything there, we absolutely have to localize the changes. So we can't allow a model to change any code anywhere depending on one change in one corner. We need abstractions for composition and reuse, and there is no way around that. We need parameterized abstractions, most likely, because we want the same thing to be usable in different contexts. Can we make them a lot more flexible than traditional programming languages? Hopefully. You can think about it as ultimate multi-platform, for example, where you have captured, you have a module in this very high-level programming language, which doesn't mention anything about the implementation platform. And suddenly, if you have implementation backends for different execution environments, you can land it in different environments through generating the right code. And yeah, you'll need to generate a lot of glue code to actually connect it to everything else in this environment, but you can definitely make a glue gun out of an LLM and generate enough to connect everything. I'm not saying it's straightforward today, but I think it's doable. You'll have to have data definitions in this, and this is probably the hardest thing you'll have to teach users, that data has structure, that there are some kind of type specifications, and like ints are not the same as strings. If you don't teach users this, there's no way they can communicate as humans, not only with computer things. So data will be the hardest part of this, most likely. There has to be versioning for evolving the whole thing. And there have to be testing contracts. We talked about this. Like there's no way we go without correctness checking. Debugging is going to be a challenge. Any questions about this? Go ahead. Very different. I mean, the biggest difference between this and COBOL is I can't read COBOL and I can't read English. Oh, sure, absolutely. So I think any high-level language has these elements in some form. So almost every language has some sort of data definition, some sort of abstractions, modules, and versioning comes just because it's text and so on and so forth. So this is the point. Like this basically distills the idea of being a programming language, because we don't have to specify behavior formally anymore, but we still need those things. Like if you remove writing code from the notion of a programming language, this is what's left. And this is more for humans than for computers. Maybe computers can figure everything out, but humans won't be able to. Another thing, which is like my pet peeve, because I spent most of my time in Kotlin working on similar things, is how do you make this new language interop with the existing ones? Like I have a huge, I don't know, Django code base or something, and I want to start using this language. Like, what do I do? Like, okay, maybe I can add a single file and teach my build system to run the right tool chain on it, and it produces some code. And of course, it can read the rest of the code, should be fine, right? But then I want, like, maybe I like it, right? How can I convert my existing code into this? And if you ever converted anything to Kotlin, you know, there was like J2K, and it was very instrumental for a lot of teams to migrate. That would be nice, right? And this is actually here, unlike the Kotlin case, where J2K is a fairly complicated tool, but it's a deterministic analytical tool. Here, you will basically need to understand what the code does to write a decent spec, unless you want to just copy the code into the spec and say, here's the spec. So the ideal spec will be actually remove everything inferable from the code and make sure that what's remained is deterministic, in the sense that if I want a generator to implement it again in the same language, it will be compatible with the previous one. So this means actually understanding code well. And well, it's a big challenge. But if we can figure this out, it will not only make it easy to migrate from any language to this one, it will be also fairly easy to migrate between languages or frameworks, or between APIs or anything. Like if we can actually capture the meaning of code, it's going to be great. I'm not saying I know how to do it, although I have some ideas. Any questions? Yeah, that's a very good point. Yeah, so sometimes it's enough, like to specify something, it's enough to write tests or show it test data even. You don't have to write all the testing code, but it'll have to, like if the system works in an input to output way, you can specify inputs and outputs, and then can just figure out from those inputs and outputs what kind of system it needs to put in between. Oftentimes, it's a working way. Sometimes it will require a lot of test data, and just a description in plain English will be nicer. But again, like it's an option always. More questions? Go ahead.
Exactly specifying the API's fitting module. What's the difference between having a dedicated language and just using existing agents and just say, okay, you write me a microservice with that API, and then go to another one and write another one with.
Yeah, that's a very good point. So if we still need to specify APIs somehow, can we use something existing for like Swagger or something else to specify APIs? Wouldn't it be nice? In general, probably yes, in some cases. Like existing API specification systems are either like REST-based or like they are based on some protocol for communicating data. And if you want any performance, you don't want every little subroutine to be a microservice. So, it's probably going to be heavily inspired by something like Swagger or Protobuf or something, but there will be subtleties that are just required for performance and for compatibility with different backends. But generally, you're right. Yeah.
There are many natural languages. So, and the language world, they don't really think about in terms of specific language. They think in terms of meaning and words in different languages. So, like, what would be the next step of breaking?
Right.
All the other major ones.
Oh, that's not bad. So the interesting the point I can answer to is the language for specifications doesn't have to be English, right? It can be any language that the model understands. But as far as I understand, the current benchmarks, current models understand all major languages roughly equally well. There is a little bias in terms of how much data is available for each language, but like for most things, most big languages, like languages with a lot of speakers, are fine. So we can finally write programs in French and in Mandarin and so on and so forth. Wouldn't it be nice? It would, but then at some point you want to hire the first non-French or non-Mandarin speaking person, and you'll have to translate everything, which is going to be an interesting exercise in itself. And I mean, that's an interesting barrier you can create, or like you can lower one barrier. Like if you don't have English speakers in your country and you still want some workforce, you can onboard them very easily with the local language. But then if you want to bring foreigners on board, it's going to be tough. But now translation is nicer with transformers. So, that's an interesting challenge for future us. Let's figure out English first. And I mean, other languages will probably work out of the box, so we won't need to do anything. It's going to be a problem for the discipline of the whoever executes this, for how they run their team. Like, do they allow, I don't know, Russian swear words in their code bases or not, or whatever. Okay, so we talked about this a little bit. And am I over time, by the way? I'm not watching time. Am I? 5 minutes, okay. So we're actually almost done. Yeah, so even if it all works, as many of you pointed out, there will be issues still that we'll need to address on top of that. And one of them can be illustrated like this. So the thing with LLMs and in general with all kinds of artificial intelligence is that models are not perfect. And sadly, they are imperfect in a different way than humans. And the difference is we're familiar with humans. We more or less know how humans fail, but we're unfamiliar with the models. We know little about how they fail. So they can fail us in very unpredictable, sort of very surprising ways. And we'll have to figure that out. So, and I think we addressed this a little bit before. We have to figure out a way to properly test everything to make sure that this like doesn't actually destroy everything. But it's a challenge, like one of them, because a model can generate the kind of code that nobody would have, no human would ever think of writing given this prompt. Yeah, so unfamiliar ways will require us to test a lot. So basically my summary is, yeah, we can have this kind of programming language. If it's made for humans, we need to account for humans, and this system will mostly be done for humans, and machines will be able to handle much more than humans can. So it will be designed around humans. And thus, the generative AI technology will probably change the programming language landscape quite a bit, but probably not eliminate programming languages before it eliminates humans. Okay, and then something like a small postscriptum from a slightly different angle on this. I just wanted to share this. If we think about a slightly different model of programming with plain English, where every human developer is an actual qualified engineer and basically gives out tasks to the agents to implement something, and they trade in code. So we don't have this English-based system, but we just have code as our primary artifact, and we just have, each of us has a team of 10 agents generating a lot of code for us. There is an interesting question there. Do you know who this guy is? You do. Who knows who this guy is? Okay, I'm old. This is Mr. Wolf. Mr. Wolf solves problems. And if you think about many agents doing things, it can be that they are stuck at some point. They can't figure out a problem. Maybe it's outside the system. Maybe the code is too subtle for them, so on and so forth. And then you, as a qualified engineer, will be responsible for fixing this. But the problem is, if for the last half a year, everything went fine, you weren't paying much attention to the code, were you? Because it was okay every time for 2 years, and you kind of got comfortable. And then it breaks, and it takes you 2 weeks to figure out what's going on. And for those 2 weeks, your bank or your high-load application is not working. Everybody's losing money. So in this kind of scenario where you are the sort of driver of a dozen agents, you will be somehow required to keep in context, which means there probably will be, I don't know, intentional sabotage attacks on you. Somebody will be breaking the code to make sure you can fix it. Because if it breaks in production, you'll have to be able to fix it. So, you know, this is the kind of future which is an alternative to what I've been talking about. When we still have code, we'll have to live on 2 different levels of abstraction, which can be tricky in its own way. It can be the winning scenario, and this is where many companies are driving right now. But it can be a unified level of abstraction if we nail the English-based programming language well enough. So, you know, we'll see how it plays out. Thank you very much for your attention. Okay, your questions are welcome. Go ahead. Then you. You first. Yeah.
So large language models are quite difficult to run. So
difficult to what?
Difficult to run.
To run. Oh, well, so, yeah, expensive. Yeah.
Yeah, expensive. So a lot of companies do not run them locally and rely on third-party services.
Yep.
But on the other hand, if you talk to any like business person, they do not want their next greatest, biggest idea to be shared with anyone outside of the company. So given that they can't, small company can't run themselves, and they do not want to outsource it to some company, how would you drive the adoption of the new language?
Very good question. So basically it boils down to, I don't want to send all of my code to OpenAI. How do I write this language at all? You probably don't want to send the prompts either. So currently, I don't think we have like very good technology to handle this, but I have some sort of possible predictions. So one is very complicated. You will probably be able to, at some point, to make the system work in a way where we don't send open prompts, and we just have sort of a cryptographic protocol between us and the model, and nobody sees the prompt or the result. I mean, it's a little bit of a pie in the sky thing. People are working on this. We'll see. That's the one thing. Another thing is code is easier than general language. It's possible that over time, the necessary models will get small enough, or the hardware will get accessible enough that will be more accessible to run your own models, either locally or in the cloud that doesn't care about your data. So, I mean, provides you guarantees about your data. So that's another option. And then maybe we'll just, get to trust the LLM vendors at some point because of their position in the, if their position in the market comes with some guarantees somehow, it can be either regulation or their business depends on it or something. It could be an answer too. Go ahead.
But because we're at a high level of pressure, like wording and syntax have a lot more meaning, and actually don't be afraid of making an environment where actually like native English speakers are at a huge advantage. It's harder for English as a foreign language to be effective because a slight change in syntax will have drastic implications on what gets generated. So while right now it might be easier for someone junior that maybe doesn't speak English to pick up coding and use the formal language to sustain themselves and get effective in the workforce, it might be that with this system will take many more years for them to be comfortable enough to be as effective as English.
That's a very good point. I think you're right. So we can create a situation where this happens. I think it's fixable, because other languages can be available in the same capacity, but also I think we can, if we really want to deal with this, as as a non-native English speaker dealing with a lot of non-native English speakers, I learned to use simpler language. In general, probably native speakers learn this too, because you get misunderstood a lot. And I think this will happen in code. So we'll get, there is pilot speak, right? So this is like a super simplified version of English that pilots use to talk to air traffic control. And we'll get something similar for this by convention, or maybe the system can enforce it, and will be necessary because even if people start using slang there, different towns may have different slang. And the model knows it, but other people don't, or misunderstand it, or whatever. And English can be hugely ambiguous in the sense that you can use phrasal verbs to express so many things. So yeah, I think you're making a very good point. There will necessarily be restrictions in this. Well, if we think about this, we restrict C++, we'll definitely restrict English. Yeah, there were more hands. Go ahead. Well, not yet. Not yet. But yeah, the interesting thing actually, the interesting thing is, in 2017, there was some demand in Kotlin developers with 5 years of experience. Kotlin got released in 2016. So with this, you can actually have 20-something years of experience just out of college by default, which is not bad, I think. Go ahead. Yeah. Okay, go ahead.
Have you thought about getting the spoken word into programming? Now, I think what you mean is if you type it down and then the code will be different. But are you planning on keep talking to them?
Okay. Yeah. So I think I'll first give you a joke and then a serious answer. So, who talks to their computer? So I'm seriously considering making a demo where what you say at your computer actually matters. It can speed up things. It's actually legitimately improving way of input, because many of us don't type as fast or as expressively as we speak. So that can be, but it can be a primary way of input. But to your point, so basically, with code, a very important function is versioning. So we have to retain it. We're not going to retain audio. It will be stored in text, definitely. But ways of input, you can now program with spoken word. It's going to be translated into text. Yeah, go ahead. That's a good question. So I would imagine it would be useful to use graphic, like especially for actual visual things like UI. You would like to sketch this. I'm not sure, again, from the versioning standpoint, how good this is. I think people at Figma figured some of it out. So I think that there are extra challenges in terms of versioning such things. If your specification has visual aspects, you have to figure out how to compare versions, how to make sure you update the right things, so on and so forth. But in general, in terms of input, we'll definitely need something. In terms of retention, I'm not sure. Go ahead. Go ahead.
How much you know about like abstraction, above the abstraction, meaning actually you're not exposing this new language, but instead you're accepting slang images or and you're backing that down.
Yeah, so with this kind of system, you can imagine the input can be super interactive. Like the agent can actually bug you about how you come at describing a problem. So it may not accept your first attempt, or it may want to alter your first attempt. And at this point, it starts to matter even less what the input was in terms of like in what medium it was communicated. So yeah, pictures, sign language, whatever, the system won't accept it literally anyway. We'll probably talk to you. We'll say, okay, so this phrase looks ambiguous. You say time flies like arrows. What actually do you want me to do? So it's gonna talk to you about it. It's gonna validate that it can interpret it in a unambiguous way, or like reasonably unambiguous way. So go ahead. One more. I'm sorry. I'll take. I'm really sorry. I'll take a question from someone who hadn't asked yet. Okay, you'll be this person. Yeah. I'm sorry. Just speak up. I can't hear you.
What if I write some module in hardware definition language?
Oh, can we do something beyond software in a similar way? I don't know enough about other things. I'm pretty sure you can do some hardware things in similar ways. I'm pretty sure you can do some like even non-computer things in similar ways. Like you can probably program mechanical engineering in sort of similar ways. So I think everywhere where there is sort of a description and a structural implementation underneath it, you can imagine something similar. You'll probably have a slightly different set of features for the language. There'll still be modules and abstractions, but like data may be not a thing there, or, but basically the same concept can be applicable to such things. Yeah. Okay. Thank you so much for your questions and your attention.